Okay, let's start. So first one is polynomial and rational equations. So let's start with the most basic one, and that is linear equations. So the trick in linear equations is simply to isolate one side with the variables, in this case x, and the other side with the constants. So by that I mean, what we do here is we move this to the other side. And recall that when you move one part of the equation to the other side, you change its sign. So by that I mean we'll obtain here x minus plus 3x rather, since we change the sign. And then on the other side, what we do is we move the constants again. Since this one is still on the left side, we move it to the other side to obtain 5 minus 9. And then let's just simplify this one. So this one will become 4x equal to negative 4. And then just simplify. So you can divide 4 both sides. And we'll be left with x equal to negative 1. And that's how we solve equations, linear equations. When we obtain an x value, then that is already the final answer. Okay, just take note here that you can actually verify this one. If you plug in negative 1 out here, what you'll get is 8. And then when you plug in negative 1 out here, you'll get plus 3, plus 5. So that will be 8. So that is correct. Okay, good. So apologies for the spacing. Let's just move this out here. Move this out here. And let's move this out here. I think that's better. Okay, good. So let's move on to this next one. So we have here 4x squared plus 2x equals 2. This time we have a quadratic equation. When we deal with quadratic equation, what we do is we simply move everything to one side of the equation. So in this case, we'll be moving 2 to the left side. So we'll have here 4x squared plus 2x minus 2 equal to 0. And then from here, take note that we have a common factor of 2 in each of these terms. So we can divide that one to simplify things and obtain 2x squared plus x minus 1 equal to 0. And then upon arriving here, we have a quadratic trinomial out here. What we do to obtain the solutions for this equation is to factor this one out. Take note that this one factors into 2x minus 1 and x plus 1. So how do you do that? Usually I use a method called slide and divide. But if you can observe that this is the factored form immediately, then no need for this one. Okay, so again, this one is gonna be equal to 2x minus 1 times x plus 1 equal to 0. And then from here, let me ask you a question. If we have a product of two numbers, when is this equal to 0? That is when either a is equal to 0 or b is equal to 0. So we apply the same idea out here. The solution for this equation is either 2x minus 1 is equal to 0 or x plus 1 is equal to 0. But in this case, we can solve this easily. So we can move this 1 on the other side. So we'll have here 2x equal to 1. Move this on the other side, and this one will become x equal to negative 1. We already have a value out here, but for this one, we still need to divide 2. So we'll have here x equal to 1/2. And this out here are the solutions for this equation. Let's just fix this one. Okay, good. And if you want, you can verify that when you plug in either these two out here, you'll get the value of 2. Good, so that's it for the first two items. That's only our example for polynomials, since basically when the degree is higher, let's say 3, 4, and 5, you'll just expect that you'll have more possible values. Like in this case, since the degree is 2, then we had 2 possible solutions. But in higher degrees, then we'll have more. And I don't want to do that long process yet. Let's just move on to another type of equation, and that is rational equations. So in rational equations, take note that the trick is to, like in quadratic, you isolate everything to one side. But this one, fortunately, is already isolated since we have 0 out here. And then you combine this one into a single fraction. So that is easy by the butterfly method. So again, by the butterfly method, we know that the denominator is just given by the product of these two. So we'll have 4 minus x times 6 plus x. So for the numerator, we simply multiply this one and then multiply this one. Good. And then let's just simplify. So let's copy this one. So upon simplifying, take note that let's first distribute this one. So we'll have 6 plus x plus 12 minus 3x. And then let's further simplify the numerator. By that I mean we combine the constants and the one with the variable. So x minus 3x out here will become negative 2x. And then 6 plus 12 out here will become 18. And then let me ask you a question again. If we have a fraction out here, a over b equal to 0, when will this be equal to 0? This will be equal to 0 when a is equal to 0 and b cannot be 0. Got it? So we need to find a certain value that would make this 0 and we'll left these two to be not 0. So we have here negative 2x plus 18 equals 0. This can easily be simplified to my spacing again is poor, so let me just fix that quickly. Okay, okay, that's fine with that. So let's first let me just move this to the other side. So we'll have here 2x equals 18. So don't be confused. So basically I move this to the other side and then just switch the places since I want x to be in the left. And then let's divide both sides, and that will leave us with x to be equal to 9. And you can check that when you plug in 9 in these two, you won't get a value of 0, which means that x equals 9 is the solution for this item. Let's just make this again. So that's it for the first 3 items. Let's move on to the last 3 for this part. So first we have 3 over x squared minus x minus 6 equal to 4 over 2x squared plus x minus 6. So in here again, first step is to move everything to one side. So we'll have here x squared minus x minus 6, 3, then minus 2x squared plus x minus 6, 4 equal to 0. So I wrote it again since this one is quite big, it won't really fit here. Good. Then here, a newbie mistake that is usually done is to apply the butterfly method immediately. But take note that that will give us a very large denominator. So the trick here usually is to try to factor out these two. This one is easy to verify that this factors into x minus 3 and x plus 2. And then for this one is quite harder, but you can check that when you apply a slide and divide method, or I don't know what method you use, you'll get these two factors out here. And then why did we do that? Well, take note that to combine these two, all we need to multiply in the first one is just 2x minus 3. And then in the next one, all we need to multiply is x minus 3. Right? Because by doing that one, we'll be left with this denominator. So we'll just be left with x minus 3, x plus 2, 2x minus 3. And again, this first one will become 3 times 2x minus 3 minus 4 x minus 3. So this simplifies things, and then let's just simplify the numerator. So the denominator will have x minus 3, x plus 2, 2x minus 3. In the numerator, we can distribute this one. So we'll have here 6x minus 9 minus 4x plus 12 equal to 0. And then let's simplify. So again, let's just copy the denominator. X minus 3, x plus 2, 2x minus 3 equal to 0. And then the numerator, take note that 6x and 4x out here, that will give us 2x, negative 9 and 12, that will give us 3. Good. Then again, like same analogy a while ago, we need to equate the numerator into 0. So we have here 2x plus 3 equal to 0. And we have space. Yeah, we have space, but let's move this one out here. Okay. Whew. And then let's just simplify this one. So when we simplify this one, we will get, so we move this one here, we'll have 2x equals negative 3, divide both sides by 2, and we will be left with negative 3 over 2. And then you can check. You can check that when you plug in this one out here, here, and here, all of these values will be non-zero. And this one is easier to visualize than earlier because this one is already in a simplified form. And observe that none of these is of the form 2x plus 3, which means that we are sure that none of these will have x equals negative 3 over 2 as a value that will make them 0. So with that, we can conclude that the final answer for this one is x equal to negative 3 over 2. Okay, then let's move on to the fifth one. So we have here 5 over x plus 3 equals x plus 8 over x plus 3. Again, same game. Just move everything to one side of the equation. So we'll be left here with 5 over x plus 3 minus x plus 8 over x plus 3 equal to 0. Then let's combine into a single fraction. Fortunately, this one is already, these two already has a denominator of x plus 3. So all that's left here is to multiply the 3 out here with x plus 3 over x plus 3. So again, no need for butterfly method. So we'll have here 5 plus 3 times x plus 3 minus x plus 8. Okay, let me just copy this one because I'm tired to keep on writing and writing. So we'll obtain here, let's move this, multiply this out here. So we'll be left with 5 plus 3x plus 9. This one out here, we'll have negative x minus 8. And then simplifying further, take note that we have here 3x minus x, so that will give us 2x. And then for the constant, so we have here 5 plus 9 minus 8, that will be 6. So check that one out. And then again, apply the same game. So what we do here is we equate 2x plus 6 equal to 0. This will give you 2x equal to negative 6. So I just move 6 to the other side out here. Divide 2 both sides and we'll be left with x equal to negative 3. But take note out here that when you plug in negative 3 in the denominator, that would actually be 0. So this one is not really a solution out here. And why is that? Well, take note that 2x plus 6 out here can actually be viewed as 2 times x plus 3. And then 2 out here is not 0. So definitely this one will determine what will be the value that will make this 0. But these two are the same. So that one is not really nice. So yeah, no solution for this one. No solution with this hat piece. So let's move on to the last one. So we have here 2x squared over 3 minus 1 equals 5x over 6. Pretty standard, same procedure, but the beauty about this is that we have constant denominators. You'll see in a while why this one is nice. So again, let's move this to the left side. So we'll have here 2x squared over 3 minus 1 minus 5x over 6 equal to 0. Then let's combine. So to combine this, we need to multiply 2 over 2 out here and 6 over 6 out here. Since 6 is equal to, has a factor of 3. So we'll have here again 4x squared. So I skipped out the process. Basically, I multiplied 2 out here minus 6 minus 5x equal to 0. And then let's just move this out here. There, good. And then here, take note that you can verify again. So I'll skip out the factoring process since that's your job to do, I guess. So in here, you can verify that this one factors into x minus 2 times 4x plus 3. And what's the good thing about having constants as denominator? Well, that is, if you didn't notice, this one completely determines what value will make our rational equation out here 0. And why is that? Because if this one is constant, then we know that this one is never 0. So this one will just be determined. And we are sure that we won't have a case like earlier, which we have a no solution. So let's do that one. So this one, x minus 2 times 4x plus 3 equals 0 must be 0. But again, when we have a product of two numbers and they are equal to 0, that just means that either x minus 2 out here is equal to 0 or 4x plus 3 out here is equal to 0. Simplifying, and this one will have x equals 2. Basically, we move negative 2 to the right. And then here, let's just move 3 to the left and then divide 4 both sides to obtain x equal to negative 3 over 4. And again, we are sure that this one is the final answer for this one. Okay, good. So that's it for the first part of our equations that you should know by heart. Okay, the next part is radical equation. Yeah. So if you have any questions or concerns or valid criticisms about this, feel free to tell that in the comment section down below. And besides that, have a great day.